Transformation matrices. Transformation matrices are special matrices that, when multiplied to another matrix, can change the value of that matrix in a specific way. Matrices can be represented on a Cartesian plane, where the x values are in the first row and the y values are in the second. When a matrix point on a Cartesian plane is pre-multiplied by a transformation matrix, the point will move in a specific way on the plane. In this video, I will be explaining the function of the transformation matrix A equals 0, 1, 1, 0, which will be represented by the capital letter A. To show you how this transformation matrix works, we will be pre-multiplying it by another matrix to the value of 2, 4, 3, 5. As you can see in this matrix multiplication, the product is a 2 by 2 matrix to the value of 3, 5, 2, 4. We now have the matrix 3, 5, 2, 4. If we compare this to our original matrix, we can see that the numbers 2 and 3 in the first row have swapped positions, and the numbers 4 and 5 in the second row have swapped positions. This is because when we multiply to get the R11 value, we multiply a 0 by a 2, which gives us 0, and a 1 by a 3, which gives us 3. So the value for this position is 3. And when we multiply to get the R21 value, we multiply a 2 by a 1, which gives us 2, and then add a 3 by 0, which gives us 0. So the value for this position is 2. As you can see in these examples, the values have seemed to swap positions. We use the same process for finding the R21 and 22 values. Therefore, the column 1 values appear to swap, and the column 2 values appear to swap. We can now plot this as a line on a Cartesian number plane to see what the change will look like. We see the new line as a reflection of the original line. This reflection will always occur for this transformation matrix across the line x equals y. When the x and y values are the same, we cannot change the values by pre-multiplying with the matrix A. We can assume that this transformation matrix will hold for negative numbers, which we will test now. As you can see, the R1 and R2 values have swapped, and the R21 and 22 values have swapped. When this is placed in a number plane, we can see a similar effect has occurred, only the new line, blue, is reflected upwards of the original line. But the reflection still occurs across the line x equals y. So as you've seen, transformation matrices can change the value of a matrix by pre-multiplying it. And we can see this transformation by plotting the values of the matrix on a Cartesian number plane. The end.